This is lesson 7.4. In this lesson, we're going to continue to talk about polynomials. We're going to be talking about factoring. Factored form is when a polynomial is written as a product of factors. So for example, we've got x squared plus 2x, and we look at those two terms and we say, hey, what is the greatest common factor of x squared plus 2x? Well, they both have an x, so I take that common factor and I pull it outside the parentheses. What's left? X squared divided by x is plain old x. 2x divided by x is just 2. So the factored form would be x times x plus 2. We're going to be using the zero product property to help us when we are doing this. So what it says is it's used to solve the polynomial equation when one side of the equation is a polynomial in factored form and the other side is 0. And then roots is what we call the solutions for this equation. So this just kind of gives you more details about that zero product property. We are going to take that property and we're going to use it to help us solve example 1, A and B. So let's write down example 1A in our notebooks first. So we've got A. Our equation is 2x times the quantity of x minus 4. Now notice it's equal to 0. We've got it in factored form. So we're going to take each part of this factored form and set each part equal to that 0. Because what it's saying is that means that one of the products or one of the factors in the product has to be equal to 0. Because in order for us to get 0 for the answer, I either have 2x that would equal 0 or I've got x minus 4 that's going to equal 0. Because when I multiply them, I have to multiply something times 0 in order for it to equal 0. So we're going to take that 2x, that's that first factor in our form here. So 2x, we're going to set that equal to 0. And then for our other possibility, we've got the other side, which is x minus 4. And we're also going to set that equal to 0 because we're trying to figure out, hey, we know one of these is supposed to equal to 0, and then figure out what our solution is. So solving just like we did in our first chapter, we're going to divide both sides by 2. So we know that one possibility for this is that x is equal to 0 divided by 2 is 0. We're going to, on this side, add 4. So we know that negative 4 plus 4 is 0. So we find that x equals 4. So our solutions or our roots for this are that x equals 0 and x equals 4. So those would be the solutions, and we refer to those solutions as roots for this. For part B, slide it over just a little bit. For part B, again, it's in factored form. We've got 2x plus 7 and 2x minus 7 for our two factors. So we're going to do 2x plus 7 equals 0. Or the other factor was 2x minus 7 also equals 0. Slide just a little bit more. There we go. All right, so let's solve the first one, just like we used to do. So in order to get x by itself, we're going to subtract 7 from both sides. So 7 minus 7 makes 0. Bring down our 2x. 0 minus 7 is negative 7. We're going to divide both sides by 2. And we find that x equals negative 7 halves. Perfectly acceptable to leave it as an improper fraction. Now, if they don't ask you for a fraction, is it possible that you could also write it as negative 3.5? As long as they're not asking you for a fraction, that would be perfectly fine. All right, on this side, we're going to add 7 this time because it had started out as subtraction. Negative 7 plus 7 is 0. Bring down our 2x. 0 plus 7 is 7. Divide both sides by 2. And we also find that x equals positive 7 over 2. So the roots or the solutions for this one are x equals negative 7 and x equals positive 7. So those are those solutions, which we call roots. Now, sometimes we have repeated roots. And what that means is when you have 2 or more roots of an equation that are the same number. So, for example, if I look at example 2 here, and it's asking us to solve these, I have x minus 1 squared. So that means that both factors in this would be x minus 1 because it's raised to the second power. So if we were to rewrite that, let's get it on our paper here first. So example 2a. We've got x minus 1 squared. So that's x minus 1 times x minus 1. That's our factored form that we were looking for. So that means I would take it and I would split it into my 2 parts, right? So I've got x minus 1 equals 0, or x minus 1 equals 0. So you're realizing, hey, I have the same equation both times. So when I go to solve, I'm going to go ahead and do these ones simultaneously since they are the same. In order to get x alone, I have to add 1. Since it's the same, I'd be adding 1 here. Negative 1 plus 1 is 0. So I know that x equals 1 or x equals 1. So our solution for this has repeated roots, and we know that those repeated roots are x equals 1. I'm going to put in parentheses that they're repeated so we remember that. And it would be that x equals 1. So for this one, we would only really have one solution because we just get that same answer of x equals 1 both times. Now for part B, we have x plus 1 times x minus 3 times x plus 1. So we know this time we've got 3 different factors for that equation. So we have x plus 1 times x minus 3 times x plus 1. And again, it's equal to 0. So when I split it, I've got 3 different things that I'm doing this time. So I have x plus 1 equals 0. Or x minus 3 equals 0. Or x plus 1 equals 0. So we're going to solve these. X plus 1, in order to get x alone, we have to subtract 1 from both sides. That makes 0. We have that x equals negative 1. For the next one, x minus 3, to get rid of that minus 3, we're going to add 3. 0. We see that x equals 0 plus 3 gives us positive 3. And for the last one here, we've got x plus 1. We're going to get rid of that positive 1 by subtracting 1. That makes 0. We find that x equals negative 1. So when I'm looking at my roots, I see that I have repeated roots here. X equals negative 1. We've got 2 sets of those. So when I write them, I just have to write that my roots are x equals negative 1 and x equals 3. Since we know that they're repeated, for this one we only have 2 options for our solutions or our roots. All right, for example 3, we are going to be factoring 4x to the 4th plus 24x to the 3rd. So let's write that into our paper here. Slide that up. All right, example 3. We've got 4x to the 4th plus 24x to the 3rd. So remember, in order to solve this using that zero product property, we have to have factored form and we have to have it equal to 0. So one way that we can look at this to try to help us for some that don't start out in factored form, right? These ones were already factored. We're going to practice with this and we're going to factor it. So I look at it and I say, okay, what is the greatest common factor of 4 and 24? Well, I know that 4 times 1 is 24, and I know that 4 times 6 is 24. Or sorry, 4 times 1 is 4, my goodness, and 4 times 6 is 24. So 4 is the GCF for 4 and 24. And I'm just going to jot that as a note. Now, do I have to write that every time on my paper? No, but for the sake of this, to help us remember how we got there, we're going to write that down. So we know that the greatest common factor for those two is 4. But I also have these x's I have to take a look at, right? And so I go, okay, well, what's the greatest common factor of x to the 4th and x to the 3rd? Well, I think, well, I know that x to the 4th is x times x times x times x. And x to the 3rd is x times x times x. So when I think about that, I'm like, oh, hey, I multiplied x times x times x in both x to the 3rd and x to the 4th. So that would be my greatest common factor for x to the 4th and x to the 3rd. Because they can both evenly be divided by x to the 3rd. So when I do that, again, my factored form, I'm going to have, just write this over here. My greatest common factors are going to be outside. So 4 and x to the 3rd, those are my greatest common factors. Everything inside my parentheses is what's left after I divide. So 4 divided by 4 is 1. X to the 4th divided by x to the 3rd is just x. Then I move on to 24. 24 divided by 4 is 6, and it was positive, so positive 6. X to the 3rd divided by x to the 3rd is 1. Well, 6 times 1 is just 6. So our factored form for this is 4x to the 3rd times the quantity of x plus 6. All right, and now example 4. Example 4, we're going to be solving. So we've got these examples here. They're not factored yet. So we're going to start by factoring like we did in example 3, and then we're going to solve like we did in the first couple of examples. So we have 2x squared plus 8x equals 0. So we've got it equal to 0, but we have to make sure that we get our factored form first. What's the greatest common factor for 2 and 8? That would be 2. What's the greatest common factor for x squared and x? That would be x. So 2x is together is our greatest common factor. 2x squared divided by 2x leaves me with x. 8x divided by 2x leaves me with 4. Still equal to 0. So our factors are 2x and the quantity of x plus 4. We're going to break it into our two sections. So I have 2x equals 0, or x plus 4 equals 0. Now we're going to solve. Slide up just a little bit. To get x alone, we're going to divide by 2. And I find that x equals 0. X plus 4, we're going to subtract 4. We have x equals negative 4. So for this, our roots or our solutions are x equals 0 and x equals negative 4. And for part B, we have 6n squared equals 15n. Now, in order for me to solve this one the way that we've been doing, I first have to get it so that it is equal to 0. So in order to do that, I'm going to subtract 15n from both sides. So now this is equal to 0. Now remember, this is 6n squared and this is 15n. They're not the same terms. They're not like terms, so I have to just write them separately. So 6n squared minus 15n equal to 0. All right, so now I got to factor it. Greatest common factor of 6 and 15 would be 3. Greatest common factor of n squared and n would be n. So 3n combined is our greatest common factor. 6n squared divided by 3n, well, 6 divided by 3 is 2. N squared divided by n is just n, so we have 2n. Minus 15 divided by 3 is 5. N divided by n is just 1. So we've got 3n times the quantity of 2n minus 5 equals 0. And now we split them up. So we have our 3n equals 0, or 2n minus 5 equals 0. So we're going to solve. Divide both sides by 3. We get n equals 0. On this side, we're going to start by adding 5 to both sides. So I have 2n equals 5. And then I'm going to divide both sides by 2. So this side says that n equals 5 halves. So our two roots or our solutions are n equals 0 and n equals negative 5 halves.